Problem 13, we have two capacitors of C1 5 microfarad and C2 equals to 12 microfarad are connected in parallel, and the resulting combination is connected to a 9-volt battery. So we have simply plus and minus. We have one capacitor C1 in parallel with another capacitor C2, and they are connected to a battery of 9 volt. We have delta V equals to 9 volt. Part 1, what is the equivalent capacitance of the combination? You know, in the case of a parallel capacitor, you can write directly C equivalent equal to the summation of C1 plus C2, which is equal to 12 plus 5 equals to 17 microfarad. This is the value of the total capacitance. And you can write in the place of these two capacitance simply the equivalent capacitance C equivalent, which is equal to 17 microfarad. Part B. Here, before part B, you can apply this relation directly, because in the case of a parallel capacitor, you have to know if we have C1 and C2. In this case, you have to know delta V1 equals to delta V2, okay? And also we have Q1 plus Q2 equals to Q equivalent. We can apply this directly, okay? And so we get finally C equivalent equals to C1 plus C2. These are the conditions of a parallel capacitors. Part B, I ask you to find the potential difference delta V across each capacitor. So we have to find delta V1 and delta V2. As I said, they must have the same voltage. Delta V1 equals to delta V2. If you look well here, we have delta V. We have point A and point B. Between this point and this point, we have nothing. We can say A. And also between this point and this point, we have nothing. We can put A. And the same for the point B. Between this point and this point, we have nothing. We can say B and B. So delta V1 equal to delta VAB, delta V2 equals to delta VAB. So they have the same voltage as the equivalent voltage. Delta V1 equals to delta V2 equals to delta V equals to 9 volt. Okay? Part C. Find the charge stored on each capacitor. I have to find Q. You know the relation between C equals Q divided by delta V. I have to find Q. Q1 equals to C1 times delta V, and Q2 equals to C2 times delta V. We have the same delta V, but we have a different capacitance C. So Q1 equals to C1, 5 times 10 minus 6 farad times delta V, which is equal to 9. So we get the value will be 45 microcoulomb, the unit of Q1, and Q2 equals to C2, 12 times 10 minus 6 times 9. The value will be 108 microcoulomb. Okay.